Hello, I'm Physics Man. Hi? Hello? Hello, I'm Physics Man and welcome to a calculus tutorial by Physics Man Education. In today's tutorial, we're going to be focusing on quadratic equations and parabolas. If you look at this graph here, you'll see a few curves sketched out. A green one, a red one, and a blue one. You may notice right away that the shapes of all these curves seem somewhat similar. And we call that shape type a parabola. Parabolas all have a few things in common. First of all, the general equation that can describe a parabola is y is equal to ax squared plus bx plus c. Now, you may remember back when we were discussing linear functions that a linear function had two parameters or coefficients. In fact, if you take out this x squared term here, you're back to a linear function. But here we have three parameters. You could also call them coefficients. When we had two coefficients in our linear function, we found that 2 points was sufficient to completely and uniquely define a straight line. We therefore should predict here that since we have three coefficients, we need 3 points to uniquely define a parabolic function. But we'll talk more about that in our next tutorial. Let's talk about a few other features that all parabolas have in common. All of them have exactly one inflection point. An inflection point is where the sign of the slope of the function changes. So, for example, this green curve has a negative slope on this side, and then it becomes positive on this side. And the point where that happens is called the vertex. Let's draw a vertical line through the vertex of this parabola. Now, at the vertex, for geometrical reasons, since the function is both continuous and smooth, we find that the slope there must be 0. But we'll also explicitly prove that when we learn to do derivatives in chapters 2 and 3. Another common feature of all parabolas is that as x goes to negative infinity, x squared goes to infinity, because the square of any number is still positive. The same is true as x goes to infinity, because infinity squared is infinity. Which means that the coefficient a can define which direction the parabola opens. So if a is positive, then the parabola will open upwards. And you have positive, y goes to positive infinity as x goes to negative infinity, and y goes to positive infinity as x goes to infinity. Of course, the opposite is true if a is a negative number, and that's when you get this downwards opening. And there you have it. That's pretty much everything we want to talk about concerning parabolas today. This has been a production by Physics Man Education. I hope you found it useful. I'll see you in the future.